So nice to meet you guys. I'll actually move forward to my slides. So raise your hand if you have an AI application or process in your organization, or you're working with customers that have AI environments. Okay, that's a good count. So I wanted to take the discussion today to a slightly different level. We have 20 minutes, so I'm sure I'll be able to cover it all. Eventually, at WEKA, we understand that the value for our customers, for your customers, is the business outcome, right? We see a very impressive line of servers and accelerators. We talked about Flash, HDDs. But eventually, all of these are what value can we provide our customers? What's the business objective that my customer needs to get to their maximum revenue, right? So we talked with a lot of customers and prospects about their future AI workloads and their current AI workloads. And we see that every customer has at least one or more AI initiative. This is actually from a few months ago, so even now it's even further. So every customer has at least one AI initiative, and it's everywhere. There is no market where you cannot innovate or get a business advantage using AI. And I think we're seeing a lot of organizations starting to see that. And obviously, the telltale hint here is if you're not using it, your competitor is probably going to use it. So you're probably better off exploring that. And obviously, there's different approaches of how you should approach an AI project. In terms of innovation, we saw a lot of innovation. Obviously, we saw some very impressive servers by SuperMicro. We see a lot of interesting accelerators, a lot of interesting MLOps environments. But we see that in storage, on the storage platforms, customers are still using enterprise storage environments, NFS environments, parallel file systems that have been designed for HPC environments. So in a sense, customers are actually looking at AI environments as the next generation HPC, using what they currently have in order to innovate on that. And that's challenging. And I'm going to try to shortly show why. If we're looking at an AI workload, it's composed out of multiple steps. And by the way, this is true, obviously, to multiple other workloads, right? Cryo-EM, life science, other life science environments, financials, but we're focusing on AI at the moment. So if we're looking at an AI workload, the challenges that exist there are manifold, and they're modern, obviously. So creating the data from multiple environments, edge location, IoT devices, buying the data from multiple environments, right? And then mobilizing it to some location where the data can be analyzed, you'll train your models on, right? So that's one challenge, moving data at petabyte scale. Another challenge is how do you transform it? How do you ETL it? ETL, extract, transform, load. How do you take the data from the format that you created it and then you modify it to your data scientist needs, right? That's a huge challenge. How do you train your model in an effective way? How do you run your inferencing? How do you run your product in your model in real time? And eventually, last but very, very definitely not least, archive. How do you archive your environment? And again, these are petabyte scale environments in a way that you do it efficiently, and it's always referenceable. So with AI, for example, one of the things that we're seeing is the notion of explainable AI. If a customer created an AI model, and the AI model has some business outcome, the owner of the model is now responsible for the model creation, for the decision process. So at any point in time, you need to say, hey, my model was trained on these 20 million files, for example. So you show that you're not biased or such. So all of these are modern challenges for AI workloads. If we're looking, and I'm sorry, I'm not going to go through all of that in a very technical way, but if we're looking at the steps, for example, the first step or the second step of ETLing, which is in AI, it's called pre-processing. So I call it the best kept known secret, right? If you're talking about GPU accelerated training, what a lot of the customers are saying is that sometimes 50 to 70 to 80% of that is actually pre-processing the data. So for example, if I have images and now I want to run an image recognition training workload. Now, every data scientist would change the images according to their needs. Maybe someone wants a square, someone wants a rectangle, someone wants a different color correction, a different distortion between the images. So every data scientist within an organization, and definitely between organizations, is pre-processing the data. That's a massive CPU workload. And it's actually, if you look at the storage part, it's a massive reads of all of the data and writing of new data, of the modified data. And it's constantly ongoing. So if I have a model that runs for 2 weeks for training, maybe out of this 10 days is actually pre-processing the data. So definitely the challenge here is I need something that can accommodate for all of these massive data changes. If we're looking at how AI is perceived, for example, and I think that was mentioned a few times here in these sessions, GPU direct storage. Hey, just use GPU direct storage if your accelerator supports it, and if not, just use something fast that can provide you a lot of throughput. And that's nice, and by the way, this is a number that WEKA showed, but that's not the only prevalent I/O pattern that you see in AI workloads. So this is a real trace captured from, in this case, it's an ImageNet workload, where we see that there's a lot of metadata. So there's massive amounts of, and this is only part of it, right? There's a lot of lookups, readers. There's a lot of metadata. There's millions of metadata operations that are being handled. And if you look at the I/O patterns, some of them are 0K. When you label data, it's a 0K file or 10K files. And there's massive, like larger files because your images or your data sets are larger. So definitely, if you look at an I/O workload of an AI environment, you can see that it's composed out of large files, small files, massive metadata workloads. Okay, so you can't get away with something that is only throughput. This is where I'll start talking about WEKA. So up until now, we talked about AI in general and what the challenges are. And that could be, by the way, not just AI. That could be accelerated computing, because we see actually GPUs or thousands of CPUs being used in other workloads as well. What is WEKA? So what we did, as Paul actually mentioned, we're a SuperMicro partner. And what we do is we take SuperMicro servers and we just, with NVMEs, and we install WEKA across them. By doing that, the servers only need to have NVMEs. And by doing that, we actually virtualize the capacity of all of the NVMEs, and we're creating our virtual namespace. And that could be terabytes or petabytes or exabytes. We do have customers in the triple-digit petabytes on one hand and on the triple-digit terabytes on the other hand. And that's it. That's the simplicity of it. Notice what you don't have here. You don't have RAID controllers, JBODs, JBOFs, storage class memory, or anything like that. You just have servers with NVMEs. And the performance characteristics that we provide are such that we provide, we distribute the data all across the storage nodes with our own distributed erasure coding. We distribute the metadata itself all across the nodes. So actually, we're running thousands of virtual metadata servers. So any I/O pattern that is being run on the system is actually being accommodated by all of the nodes. And we see actually customers benefiting from that, and I'll definitely show it. So we have the performance characteristics. I think there was a few mentions about having a lot of drives on a server so you can get a lot of performance, because we see customers copying data to the local GPU servers to work on the data. With WEKA, we eliminated that notion. Will be faster than the local NVMEs on a server. And obviously, if we had more time, I would explain how, but maybe if you jump over to our booth, I'll be glad to elaborate. But the performance characteristics of the cluster is that it will be shared, distributed by all of your compute clients, and faster than your local NVMe. Bless you. On top of that, we support accessing the data with all protocols. So you can access the data using S3, NFS, SMB, using our own POSIX client. So imagine a pipeline, imagine a workload where you need to feed petabytes of data to your environment. You could feed it with any protocol and then analyze it at a higher performance protocol, right? So you don't need to copy data. We see customers copying a lot of data between different environments. There's no need to copy the data. Push it one way, work with it another way. It will just be there, and it will be higher performance. What we can also do, and definitely joining what Paul mentioned regarding HDDs and NVMEs, even though we created an environment that has all of the data structures and the distribution on NVMEs, we do believe that there's reasons for other more cost-effective storage. So what we do is we're able to virtualize our capacity between the flash tier and the object storage tier, and an object storage tier, one or more. So imagine a multi-petabyte object store being fronted by a smaller scale WEKA environment, and what we'll do is we'll present that entire joint namespace to the compute servers. So currently, we see customers trying to move data between different environments themselves, between HDDs and SSDs, using HSM or backup softwares. These are things that don't work at petascale environment or at even multi-terabyte environment. So being able to say, we're doing all of that data movement ourselves, the compute servers just mount the WEKA environment and work with it, actually simplifies and enable a lot of use cases. And maybe I'll even mention a few of them. Additionally, we can throw data to other clouds or private clouds or public clouds as needed. In terms of performance, I made some bold claims, but here's some WEKA numbers. By the way, I hid the other solutions because I don't want to black eye anybody, but this is our number. We did a comparison for throughput for 1 petabyte. This is the WEKA number, 1.2 terabyte per second for a 1 petabyte system. By the way, these are the SuperMicro Big Twins environment. And we compared it to the throughput numbers of other parallel file system and other NAS appliances. In terms of throughput, other parallel file systems were closest to us, right? And these are their hero numbers, so their acclaimed best performance numbers for 1 petabyte of capacity. They were like a fourth or a third of what we can do. In terms of IOPS, nobody's even close, right? Parallel file system or NAS appliances are not even close to what we can provide. So the message is we have an environment that we install on SuperMicro servers that can virtualize the capacity between object store and flash environments, so it's definitely a very nice TCO, and it provides all of the performance characteristics that you need to accelerate your AI and other workloads. Here's a slide I like. Maybe I'll focus on that, because I think if there's one slide I need to show, that's what customers are looking for. You had a workload, and this is a real customer workload. It's a large autonomous car company that is using WEKA. They had an AI training workload that took 2 weeks. Just by implementing WEKA, we dropped it to 4 hours. So 2 weeks to 4 hours, that's the value. In terms of performance, that's the value. You can now do 84 times more workloads at the same amount of time. And that's something that we're seeing on and on and on. This is not unique. We see other workloads compared to other environments which are 54 times faster, 80 times faster. So that is eventually the business value for the customer. Here's some customers that with use cases that I can actually talk about. Genomics England is a very public customer. They have 90 petabytes of our solution on SuperMicro servers connected to actually to a quantum active scale object store. And we actually accelerated their time to genome sequencing. We actually, sorry, that's the acceleration, 50 times. We actually reduced the price significantly. And we frankly, we enabled them to have an environment at a petabyte scale where they couldn't have had before. Now they're able to do it geo-distributed across 3 data centers. They're using WEKA to send the data between different data centers. So now they have backup and DR. Definitely, it's compelling. That other customer that I mentioned, 1 week to do a 1 year's worth of work, right? That's impressive. They have triple-digit petabytes of an NVMe environment because you can scale over the NVMe capacity to petabytes, or you can combine it with object store, as these guys did. They have tens of thousands of GPUs on multiple locations. They have thousands of GPU servers, right? So definitely this is built to accommodate for all of that. Another customer, Too Simple, an autonomous truck company that we work with, multiple data centers, multiple petabytes of capacity within flash and object, and definitely accelerating their workload. And Too Simple and Genomics England are public. You can simply Google it. And I think with that, I'll finish. And we have some time for questions. If you don't ask, then I will ask. Yes?
How much is workload for the erasure coding?
Sorry, how much?
Is it workload with erasure coding going west to east?
So everything that I just showed is with erasure coding enabled, obviously. So all of our system is protected with an N+2 or an N+4 environment. So all of these numbers are with erasure coding. There's no way to disable it. You don't need to disable it. I can actually elaborate afterwards how we're doing it in such an efficient way.
What's the network requirement?
The network can be anything between 25, 100, 200, 400. Could be InfiniBand, could be Ethernet. More questions?
We installed a special client on the client side.
Sorry, I didn't get the question.
Is there any special client software installed on the clients? Because it seems from that, so you have NFS.
When you're using NFS or SMB or S3, there's no other client. When you want to use our high-performance client, then you need to install our client that runs in user space, containerized, segregated. And yeah, that client implements our own design, our own way of accessing the files that provides that high performance. Any more questions?
Are there any limitation for that drivers on the client side? I mean that you support only particular Linux distribution on certain version, or
a lot of limitations. We support all Linux
so
versions.
So you distribute it as a source
application.
code?
We distribute it as an installable application that runs in user space. It supports any version of Linux, all of the Red Hats, all of the Ubuntus. We also see some SUSE clients. That's the limitation, essentially.
Thank you.
In case of installing the software to the clients, do the clients require compute capacity or dedicated core or something like that?
So when you install the client, you have multiple ways of installing the client. The highest performance fashion is to say, hey, I'm installing the client. I'm allocating one CPU core for that client, and that's the only requirement. And there's a certain memory footprint, 1.8 gigabyte of RAM. That's it. And then we take that CPU core using C groups, and that's what we work. You can also, by the way, say, hey, WEKA, you can use more CPUs than one. Or you can say, hey, WEKA, you're sharing the CPU with other applications. In such case, we act as a regular client, and as we get more IOs, we spin up the CPU cycles for that client. So there's different options. We see actually customers choosing one or the other. We don't need any dedicated card or anything like that.
Thank you.
And by the way, it's running in user space. A lot of the antagonism about clients is that they're running in kernel, and then if the client explodes, then your whole servers and compute and application now went away. So we're running containerized in user space. Nothing that happens to the client affect the other applications. More questions? If not, I have a question. Who knows? Anybody knows Tabasco, the sauce? Anybody like Tabasco, the sauce? No? It's not famous in Europe? So it's a very distinctive sauce, right? It has this red color. Who knows what AI environment they're using to make sure that it's always the same color? No? So the answer is nothing. The answer is that they're actually working with something that's called a bâton rouge, a red stick, and they go and compare it to the peppers, and when a pepper is with that color, they just take it, and that's their AI. So the answer is you don't always have to complicate things, right? So, and we make it simple. Any questions for Paul on anything on the SuperMicro servers? How do we work the licensing? So first of all, you're able to purchase it through SuperMicro, and then ask them the licensing. But generally, it's per usable capacity. Yes. So and there's obviously there's also some customers want just to access us as a fast object store. So that's a very basic license according to the capacity. When we have our flash capacity, it has a certain price. When we have our object store capacity, it has a very symbolic price. Basically, that's it. It's not that complicated, but yes, it has a few knobs.
So are you suggesting that almost the company could rip out and replace all their storage infrastructure for WEKA? If they are doing HPC and AI, then they can also use it for their enterprise applications, et cetera, et cetera?
Actually, I'm not. I don't want to boil the ocean here. We have a large addressable market. Definitely, if you look at the addressable markets, HPC is a market. AI is it's becoming actually a larger market. There's other, data analytics is also a very, data analytics is actually going through all of these markets. So definitely that can be used as well. I'll tell you where I wouldn't position WEKA. Places where I'll recommend one of our other NAS appliances companies, your VDI, your VMware. You don't necessarily want to buy WEKA because of that. We do see customers that bought WEKA for the AI, the HPC, the analytics, and they threw in WEKA. But we don't target WEKA for that. Maybe in the future, but right now, that's not where it is.
Thank you.